Hello students, today we are going to start our next chapter, that is chapter number 7, integration. So when we hear about the word integration, the first question arises in our mind that what is integration? So first we have to understand the meaning of this word. Integration is basically just the reverse process of differentiation. Integration is just a reverse process of differentiation. It means whatever be the formulas or the conditions we learned in our previous chapter, that is differentiation. So here we are going to apply all the reverse process of all that concept. For example, in differentiation we had studied about the derivative of 10x. The derivative of 10x is sec square x. So here in integration, when we integrate the term sec square x with respect to x, so we get 10x plus c. So this is the integration of sec square x. Clear? So now next question arises in your mind that why c is added here? Why this c is added here? This we will understand in our later portion, but right now we have to understand what is integration. So now I hope it is clear to all of you. Integration is only the reverse process of differentiation. Like we can take one more example, the derivative of log x. We know the derivative of log x is 1 upon x. So now if we integrate the term 1 upon x with respect to x, so the integration of 1 upon x is log x. So the integration is log x plus c. So these things we are going to learn in this chapter. Okay. So now moving forward, first of all we have to understand the types of integration. So here basically two types of integration are there. First one is indefinite integration and another one is definite integration. So what is definite, what is indefinite integration? Indefinite integration means the integration in which we are going to perform in an open limit, means when there is no limit is available for any function, those functions are comes under indefinite integration. And for those functions which are bounded with any specific limit, they comes under definite integration. For example, if someone asks that find the integration of 10x dx, here they never mention that from which part to which part you have to integrate this function. Now for definite integration it always gives you a limit, like we have to integrate pi by 4 to pi by 2 for 10x dx. Now you are bounded with a specific limit. You only need to integrate only for this region. You left all the region, just integrate only for this region. So this is basically definite integration and this is indefinite integration. If we recall it, then indefinite integrals are those integrals which does not contain any limit, and definite integrals are those integrals which contains a specific limit. And it also has some properties which we are going to study under this section. So now we are going to start from indefinite integration. So indefinite integration is containing some specific topic. First one is basic formula method. First part is basic formula. Basic formula means whatever be the formula we already learned in differentiation, we got the reverse formula for this function as well. Like for example, we know very well the derivative of x to the power n is nx n minus 1. Here if we find the integration of x to the power n, if we need to find the integration of x to the power n dx is x to the power n plus 1 upon n plus 1, and here c is always added in the indefinite integration. This part is compulsory. Now, first of all, I would like to tell you why this c is added here. Okay. Suppose if someone asked to you that the derivative of the function x square plus 3x plus 2. So you can differentiate this function in a very easy manner, that dy upon dx is 2x plus 3. If someone again asks you convert this function in this previous equation, so you can integrate this function 2x plus 3 with respect to x. So here 2 is constant, the differentiation for x means x to the power 1, the derivative for x to the power 1 is 1 plus 1, 2 means x to the power 2 upon 2 plus, and the integration of constant is x. So 3 is constant and the derivative and the integral of constant is x. So now when we simplify this, we get x square plus 3x. Now compare both the equations. Is these equations are same? No. Here it contains 2. Here it does not contain any positive constant or any constant. Why? Because this constant will be eliminated at the time of differentiation. So for balancing of this constant, which was already been 0 at the time of derivative, so for balancing these constant terms, we always need to add a constant c. So here c term balance the equation, balance the constant factor which will be eliminated at the time of differentiation. That's why indefinite integration always contains a constant. Okay? Now, write down the next formulas. We know very well the derivative for log x, that is 1 upon x. So now if we integrate to 1 upon x dx, we get log ex plus c. Clear? The differentiation for e to the power x, that is e to the power x. So when we integrate e to the power x, here it is e to the power x plus c. Okay, here we are having some more basic formulas which I am going to share with the help of PDF. So you can check it from the PDF. Okay, now integration having only one principle. We only integrate those functions whose formulas or whose equations, whose conditions are known. Clear? In differentiation, we always differentiate each and every term. What was the principle? We have to differentiate each and every variable of the function. But integration has some specific rule. We only integrate those functions which, on the basis of which we are aware about the formulas. We only integrate those functions whose formulas are known. If formulas are known for any function, then we are not able to integrate that function. Clear? So now that's all for basic formula method. Rest all the formulas I will share with a PDF file. Okay? Now moving towards our next topic, that is substitution integration. Or we can say substitution, or we can say integration with the help of substitution method. What is substitution? Substitution is like, for example, if we need to find the integration of 10x, if we need to find the integration of 10x, in derivative and differentiation, we never saw the integration 10x for any of the function. We don't know any function whose differentiation is 10x. Clear? So we cannot say directly. So here, first of all, we need to convert this function in sine or cos. So we can write this as a sin x upon cos x dx. Clear? Now, this substitution method is basically to substitute to suppose a value, a function in another term. Let's suppose sin x equals to t. Here we don't know the formula for this. We don't have any conditions to integrate this function. So we can assume sin x equals to t. Now when we change the we need to let cos x equals to t. Okay. Now when we let cos x equals to t, we need to convert all the x variable into t. So for converting this, we need to differentiate this function. So differentiate both sides. So we get dt upon dx. The derivative of cos x is minus sin x equals to dt upon dx. Now we need to find the value of dx. So dx is equals to dt upon minus sin x. Now substitute this in the given condition. So here we can say integration value of dx, sin x is as it is, cos x is t, dx is minus dt upon sin x. Sin x will cancel out this. So what we get? Minus dt upon t. Now the integration of 1 upon t is log t. So we get log t plus c. And the value of t is cos x. So that is log cos x. So now we can say the integration of 10x is minus log cos x. Or if we simplify this negative sign, we can also write this as a cos x to the power minus 1 plus c, and cos inverse is known as sec x. So now if someone asks you the integration of 10x, so you can clearly say the integration of 10x is log sec x or minus log cos x. Clear? So this is the substitution method. In this method, we always need to search that we always need to assume for that function whose derivative is available in the given equation. For suppose, if someone gives you 1 upon x log x, 1 upon x log x. In this question, we know very well the differentiation of log x is 1 upon x, and here it is available. So in this question, we assume log x equals to t. So when we differentiate this function, we get 1 upon x. The derivative of dt is dt upon dx. So when we find the value of dx, we get x dt. Now substitute the value here. We get integration 1 upon x, log x will be t, and the value of dx is x dt. X will cancel out this. 1 upon t is log t plus c, and the value of t is log x. So answer is log x plus c. Clear? So this is basically substitution method. I hope it is clear to all of you. Now moving towards our next method, that is integration by parts. Integration by parts means in derivative we already learned about the product rule, division rule. Now here in integration there is only one rule, that is integration by parts. So the formula for this is if u v, these are the two different functions. So the derivative the integration for this u integration v dx minus integration d upon dx of u integration v dx u. So this is the overall formula for integration by parts. Here the one specific thing we need to remember, that out of the two functions, whom will we consider as u and whom will we consider as b. So it will always selected from the Eilert rule. Eilert rule is basically I stands for integration. Sorry, I stands for inverse. If inverse is available in any function, then that inverse function will be considered as u and remaining another function will be considered as v. If inverse is not available, then we can check for logarithm. If logarithmic function is available, then it will be considered as u, otherwise another function will be considered as v. A stands for algebra. If both these functions are not available, then algebraic term will be considered as u and remaining another term will be considered as v. After this, T stands for trigonometry. T stands for trigonometry means if all these three terms are not available, then trigonometric term will be considered as u and remaining rest of the term will be considered as v. And at last, E stands for exponential function. If all these four functions are not available, then we can consider that exponential function as a u and remaining next function will be considered as v. Clear? So this is our integration by parts. For suppose, if we take an example that integrate x sin x. If we need to integrate this function, so here first we need to check with the help of Eilert rule which term is u and which one is b. First one is I. Inverse is not available, then ignore this. L. Logarithm is not available, ignore this. Then A. A means algebra. Algebra is available, so this function is u and this is v. Now substitute all the values in this equation. So the integration for this is u means x, integration v means sin x dx minus integration d upon dx of u means x, integration of v, that is sin x dx, and it will be dx here. Now simplify this. X, the integration of sin x is minus cos x minus the integration of, differentiation of x is 1, integration of is minus sin x, minus cos x, minus will be comes out. Now simplify this function, so we get minus x cos x, the integration of cos x is sin x. Here all the integration is complete, so we can add this. So our final answer is sin x minus x cos x plus c. This will be the answer for this function. I hope it is clear to all of you. Now please pause the video to note it down. Now moving towards our last topic of indefinite integration is partial fraction. Partial fraction. So what is partial fraction? Partial fraction means we have to separate the denominator part of any rational number. For suppose, if someone gives you x plus 2 upon x square, then you can simply separate this term x upon x square, 2 upon x square. It is clear to all of you. If we need to separate the numerator, then we can just simply divide the denominator for both the terms. Okay. Now, if we need to separate this function, are we able to separate this denominator? Means x plus 2 and x plus 3 will be separated with the individual fraction? No, we are not able to do it directly. So for the separation of these denominator part will be solved with the help of partial fraction. Okay, it consists of specific formulae, or that they are not basically formulae, they are some conditions. Conditions like if any function looks like this, x plus a, x plus b, then it will be p upon x plus a plus q upon x plus b. We just need to find the value of this p and q, put it here, and we get the separate value of this denominator. If any function looks like this, x plus a whole square, x plus b, then it will be separated as x plus a plus q, x plus a to the power whole square plus r x plus b. Clear? Now, if ax square ax plus b upon x plus a or x square plus b, here when we get the value of x in any complex form, then the first term will be written in denominator of p and another term will be written as qx plus r divided by x square plus p. Now simplify this function and find the value of pqr for all the terms. For example, let's take an example. If someone gives you a question that x plus 3 and x plus 4, separate this function with the help of partial fraction. So what we can do, first of all, we can consider p upon x plus 3 plus q upon x plus 4. Now here we are saying both the functions are equal, then when we simplify this, you also get this function. Just simplify this with the help of LCM. The denominator is x plus 3 and x plus 4. Here 1 upon x plus 3 and x plus 4. Now this will cancel out. What is left? 1 equals to px plus p4 plus qx plus q4. Now separate the term x term, the terms with coefficient x. Now 4p, okay, I did something wrong here. Here it is 3. 4p plus 3q. Now both the functions are equal. It means the coefficient of x in LHS and RHS are also equal. Here in LHS there will be no value for x, then the coefficient for this is 0. Here it is p plus q. In the same way, 4p plus 3q is equal with constant, that is 1. So the value of p is minus 2. Substitute it here. Minus 4q plus 3q equals to 1, minus q equals to 1, so q is equals to minus 1. So we get the value of p is plus 1. Substitute this plus 1 and minus 1 in this function, so what we get? 1 upon x plus 3 minus 1 upon x plus 4. So this is the partial fraction of this given function. Now if we need to check this function, just simplify this, take the LCM, we get this function. If we get this function, then our fraction is absolutely correct. I hope it is clear to all of you. Now please pause the video to note it down. After that, we are going to start our next topic, that is definite integration. Now moving towards our next topic, definite integral. Okay, before starting this topic, one thing I would like to tell you about the partial fraction. That is, partial fraction is only applicable when the order of numerator will always less than to the order of denominator, or we can say degree of denominator. When degree of numerator is less than degree of denominator, then only partial fraction is applicable. Otherwise, first of all we need to convert in this condition, then only we are able to partially fractionate that function. For suppose, if someone gives you x square plus 1 upon x square minus 1, and someone asks to partially fractionate this term, so first you need to simplify this. Here both their functions are x1, x square, so we can minus, add and subtract 1. So we can write this. It is also correct. Okay, 1 will cancel out by 1, we get the same function, means it is correct. So now separate this function. 2 upon x square minus 1 will be x minus 1 and x plus 1. Now this will cancel out this, 1 plus 2 upon x minus 1 and x plus 1. Now we only need to partially fractionate this term. Here it is 1, we know the integration for 1 is x. Now we only need to apply partial fraction on this function. Clear? Now come towards our next topic, that is definite integral. Definite integral is exactly same with the indefinite integral. The only difference is limit. So whenever we differentiate any function, at last we need to substitute the limit. For example, we just solve the integration for 10x. Now if this will be come with a limit, that is pi by 4 to pi by 3. Okay, then always first we need to substitute upper limit, then minus lower limit. We already learned about the integration of 10x is log minus log cos x plus c. Now substitute the limit, that is pi by 4 pi by 3. Substitute it. Minus log cos pi by 3 plus c minus log cos pi by 4 plus c. Simplify this function. Cos pi by 3, cos 60 is 1 by 2. So minus log 1 by 2 plus c, minus plus log cos pi by 4 is 1 by root 2. So it will be 1 by root 2 and minus c. C will cancel out by this. So when we simplify this function, so we get minus log 1 by 2 plus 1 by 2 log 1 by 2. We get minus 1 by 2 log 1 by 2, or we can say log root 2. So this is our final answer. So definite integration is almost ditto same with the indefinite integration. The only thing is at the end of the definite integration, we just need to substitute the limit, upper limit minus lower limit, and we get the answer. Okay. Now definite integration consists some specific property. With the help of those properties, it is easily to find the solution of any integration which consists limits. Okay, so write down the properties of definite integration. properties of definite integration. Our first property is f(a) to b fx dx is always equals with a to b ft dt. Means if function will be given in x and the limit is a to b, then we can simply change that function in terms of t. If we integrate the function x dx, or we can integrate 1 to 2 t dx, t dt, both the functions are same. This will be stated by property 1. Property 2, if we need to interchange the limit, suppose right now limit is given a to b, if we need to interchange the limit, we just introduce some negative sign and simply we can change the limit. So this is our property number 2. Now property 3. Property 3 is split of limit. Suppose we need to integrate a to c of any function, then it will be written as a to b fx dx plus b to c fx dx, where a is b, means b always lies between a and c. So it will be written as a to b, then b to c. Both are equal. Clear? Now moving towards the fourth property, that is, this will be the important property. If limit 0 to a fx dx is given, then it is also equals to 0 to a f of a minus x dx. The integral value for both the functions are equal. Now moving towards the next property, that is property number 5. If limit a to b f of x dx is given, then it is equals to a to b a plus b minus x dx. Both the properties are same. If we add a plus 0, then we get a minus x. Here a plus b, it will be written in this form. Clear? Now moving towards sixth property, integration of minus a to a fx. It consists two formulas. Either it will be considered as 2 twice of 0 to a fx dx. It will be only possible when function is even, or we can say f of minus x is equals to f of x. In that case, the function will be considered as in this function. If the function is odd, then the integration for that function is directly 0. Clear? So this is property 6, and last property 7. 0 to 2a fx dx. So here we can write 0 to a fx dx when f of 2a minus x is equals to fx, and 0 when f 2a minus x equals to minus fx. So these are the basic 7 properties of definite integration. On the basis of these properties, some question will be asked in your final examination. Now please note it down. That's all for this chapter. Now we are going to solve some basic question on the basis of integration in our next video. So that's all. Thank you.